Hi everyone, welcome to today's webinar, your first step to running applications with containers. My name is Daniel, I'm a solutions architect based in Melbourne. We're also going to be running live Q&A throughout the session, so if you have any questions, please enter them into the chat window and we have solution architects standing by who are going to answer those privately throughout the session. And if we have time at the end, we'll cover off any of the common questions that have been asked. And any questions that we can't answer today, we'll send out in a fact sheet after the presentation. So getting started today, what we're going to cover, it's a 100 level introductory session aimed at helping getting started and understanding using ECS and containers. It's about being able to take your first steps. And at the end, we hope that you're going to understand some of the Docker features, how to use ECS, and how to be able to deploy containers with ECS. So first we're going to dive technically into what containers are, and then we'll cover off some of the benefits and why containers are such a hot item at the moment. Then we'll touch on some design considerations when using containers, particularly around microservices. Then we'll look at the EC2 Container Service, the EC2 Container Registry, and then we'll wire it all together with a demonstration and show you how it all works. But first, what are containers? So containers are a method of virtualizing your application, its dependencies, and running them all in a single resource isolated process. So as this picture shows, the containers are all sharing one guest operating system. So they can allow you to easily package up your application code, the configuration, and all of its dependencies into one building block for fast deployment. We called that building block a container image. And it can run on any machine running the Docker engine. And today we're only talking about Docker. There are other container versions around as well. So people often ask, well, what's the difference between a virtual machine and a container? So the differences are highlighted by these diagrams. And on the left, we have an example of a virtual machine. And you can see we have the server, the host operating system, then the hypervisor, and then we're running a whole lot of guest operating systems on top of that before we get into our application layer. On the right, we have our server, and then we've got our host operating system, and then our Docker layer. And all we have to run on top of that are the applications and libraries that are required to run your application. So if we look at a virtualized environment and we wanted to run a different version of the software or a dependency, we're going to have to try and share that on one virtual machine, or we're going to have to run an entire new virtual machine, including the operating system. Whereas by using containers, we only need that one single operating system, and then the applications on top that are required are called distributed in a container. We can also compare that an entire operating system is generally going to be gigabits in size and take minutes to launch, whereas containers normally in the megabytes and can be deployed very quickly. So containers have been around for a while and been evolving into what they are today. So in 1979, chroot contained a process and all its children to one area of the file system. And then that's been iterated and improved on. OpenVirtuoso in 2005, for example, added CPU constraints to containers. And then we get to 2013 when Docker was released, and that made it easier to move these Docker images around with a tooling that they provided, and it continues to grow. We've had over 450 million downloads since 2006. And in 2015, AWS introduced the EC2 Container Service to manage containers at scale. So why do we see people using containers? Because using a container, you can run and build exactly the same container on the developer desktop that's going to end up running in your production environment. So this solves that problem of the small differences that we would see between development and production environments. Small differences that usually ended up with the conversation, well, it worked in dev, I'm not sure why it's not working in production, are removed. Also, using containers, each of the components of an application, they can all be run in a separate container. So that improves the developer efficiency. So previously, if your component required a newer library or version, all the components that were using that library would need to be tested before we could deploy them. And without containers, developers had very limited ways of tracking the versions of everything outside their application. Tools like Puppet and Chef can be complicated. Docker has a manifest Docker file that's easy to maintain and track the versions of your container, so you can inspect the differences and roll forwards and backwards to previous versions if you need to. Docker images are also built-in layers, so that means that existing components that don't change don't need to be rebuilt. So this makes the builds faster. Starting a container is just the same as starting a process, so they scale very fast. And some processes, when you're running, they don't need all the instance capacity all the time. So with a container, you've got flexibility to use that unused capacity with batch job, for example, running in its own isolated process on the same instance. So all this adds up to consistent environment, increased developer productivity, better version control, and improved operational efficiency across our compute resources. We understand and know what containers are now, and we can easily ship smaller units of our application around. We need to consider how our application is designed to take full advantage of that orchestration and control that is now available to us. So we'll look at some of the different application design patterns we see. Monolithic is probably the most clear-cut, where your application is tightly coupled. And if you change the functionality in one part of your application, you're going to have to test the functionality of the entire application. All components are likely to depend on the same backend or data store or memory, for example, as well. We've got service-oriented architecture where we break our monolith into different application domains, but the business logic might still span several domains. And it's common in this pattern to see a form of middleware that's still tightly coupling some of the different components. Changing one part of our application is still going to cause testing of several different components. And finally, we have the microservices, which are very many small components, and each component exposes a service that's going to abstract whatever language or data store is sitting behind it. So the business logic is living inside a single domain, and you can make changes so long as you don't break the functionality of your service. So let's translate this to a business case and use an e-commerce application as an example. So let's say a new software package is released, and it's going to save our business $500,000 a month because it's going to drastically increase our shipping efficiency. In our monolith situation, we find that the software version to include in our application is using a library older than we're already using. So we have options that we can either run it in an untested environment, we can wait for everybody's compatibility to align, or go back to the vendor and try and get them to help us align it. So we could be looking at months before we see that application and realize the business benefit in production. Whereas if we're using microservices, we could create a container with the environment that's required and supported. And so long as that service passes all its test cases, then we can quickly release that into production and realize that cost saving much faster. We can also start to see that we can have many developers working safely on different parts of our application and deploying at different times. So apart from the deployment complications, monolithic applications also have difficulty breaking out any of the components to scale individually. So here we have an e-commerce application. We've got like the order UI, the shipping service. And if we need to scale any of those, we have to scale the entire application. So let's say the shipping service needs some extra CPU. We've got the options that we can scale up, and that's maybe put more CPU or memory in the machine that we've got, or we can scale out, and that will involve adding an entirely new machine to scale onto. Whereas if we look at that in a microservices example, so here we've broken out, they're no longer tightly coupled. We've got our order user interface, user service, and shipping service running in totally separate containers, and then we need to go and scale that. We can see we can start to scale applications or parts of the application independently. And we also notice now that we're starting to get some more containers to manage. And as that continues to grow and our application continues to grow and we get more users and services, it gets harder to manage. So let's say we've got to deploy 50 containers of X and 10 containers of Y. And this is where Amazon ECS comes into play and helps with that management of large clusters and instances and putting those containers across those instances. So I've got easy cluster management, flexible scheduling. It's integrated and extensible, secure, and designed for performance at scale. Now we'll dive into each of those individually. So ECS looks after the cluster management. Eliminates the need for you to have to run and manage your own cluster. You don't have to install or manage any cluster software. It manages the cluster state, for example, scaling and adding and removing instances. It manages the containers and the distribution of those containers across your instances. Provides control and monitoring of what's going on within your cluster, and allows you to scale from 1 to tens of thousands of containers. It offers flexible scheduling. Now, when it comes to scheduling, there's some confusion. There's sometimes some confusion because it's not about running containers at certain times of the day, like 9 AM, for example, for 4 hours. Container scheduling is referring to where the resources will be allocated to complete the work that's required. So to use an analogy, if we were packing a moving truck and we wanted to maximize it to fit the most items per trip, we'd have a packing schedule to achieve that. And that might be, okay, we're going to put big boxes in and then the little ones around it. But if we wanted to, instead on our move, spread our valuable items between multiple trucks to minimize the risk, then we'd have a different packing schedule because we have different requirements for our move. So ECS provides different scheduling options, and you can choose one of our ones or one of the provided ones for your application. For example, we have availability zone spread, where you can spread your containers across different availability zones to ensure high availability. So you can decide which scheduling option is best for your application, or you can use an integrated third-party scheduler if you have your own specific business or application requirement. And you might also want to consider looking at Blocks, which is our open tooling released by AWS for building custom schedulers. One of the benefits with ECS is that it's integrated across the AWS platform. So IAM, security, elastic load balancers, CloudWatch, CloudTrail, you're going to get all the benefits of working within AWS and communicating with the other AWS services. It's also extensible through APIs, so you can use your own scheduler, for example, but you can also connect it with existing software for your software delivery process. So you might already be using tools that integrate with ECS, CircleCI, CloudBees, Twistlock, Datadog, for example. So it may be worth checking those. From a security perspective, it's important to realize that the instances that are running with ECS are just your EC2 instances, running in your VPC, just like any other instance you would launch on the AWS platform. So this means you get the same VPC security with security groups, network access control lists, IAM roles. You can also put them into public or private subnets and communicate with them over an IPsec VPN or Direct Connect. Or you could even take advantage of dedicated instances if you wanted to. Being AWS, it's been designed for scale, built on technology developed for many years. You can launch clusters with thousands of instances and schedule tens of thousands of containers in seconds. The common use cases we see people using ECS, as we discussed already, microservices and distributed applications lend themselves to containers very nicely because it allows you to create distributed applications and break them apart into independent tasks and processes. For example, you could have a separate container for your web server, your application server, your message queue, and backend workers, and they can all coexist on the one instance, for example. You've got that isolation to be able to run those components side by side. For batch and ETL jobs, the benefits there are, well, one, you can use the unused capacity to be running a batch job while other containers are running. But because the processes are isolated, you can run different batch jobs on the same instance. And from a CI/CD perspective, as we discussed before, because you've just got that one Docker image building block that you're moving around, you can push that to a repository, for example, have the test cases picked up and run on that same container, and then deploy exactly that same container onto your production servers. So you avoid having an application that works in development that then fails when it goes into production, because you always got exactly that same image. The components that make up ECS, we're going to go into these in a little more detail, but we'll just point out and talk over them quickly, because we have clusters, which is a collection of the container instances, and sort of nested within those clusters, we have our container instances. Within the container instances, we're going to have our containers. We have a service, which is maintaining a number of tasks running across our container instances. We have the task definition, which is going to say how each of these containers should run, one or more containers should run. And then we have the Docker daemon, which is running on our instances, executing the containers as we ask it to. So first, let's look at the cluster, which is the collection of our EC2 instances. Generally, we try and run them across multiple availability zones for high availability. They can be made up of different instance types, but they are region specific. And a container instance can only belong to one cluster. So an instance is just an EC2 instance owned by you, like we said before, running in your VPC. You can even SSH to it if you want to. The Docker daemon's running on your EC2 instance, listening on a local socket. And then we have the ECS agent, which is doing the communication between ECS and the Docker daemon. And that's open and publicly available on GitHub if you wanted to have a look, but you can also use that to build your own custom machine images or AMIs if you want to integrate with ECS. The task definition is where we're going to specify what's going to run. So we can have one or more containers run, specify the amount of CPU or memory that's going to be available to that container. We can use links, which is going to provide network channels between containers. And we can add volumes to persist data between the containers. And task definitions are checked by name and revision. So we can go backwards and forwards across different versions of that. And we have the task, which is essentially just an instantiation of that task definition. It runs on the instances within the cluster. And we can have one or more containers, like we might have tightly linked containers, which is like a sidecar model, where you could have your primary container being a web server, for example, and you might have a logging container that launches at the same time within a task. And we have a service. The service allows you to run and maintain a number of different task definitions within a cluster. So if any of those tasks stop or fail, the scheduler will attempt to relaunch another instance of your task definition to replace it. And it's always trying to maintain that desired count, like an auto-scaling group. The service can run behind a load balancer, and that's going to distribute traffic to the tasks that are associated with it. We're going to have a look at that in the demo. We've got task placement, and that's where we talk about where we're going to put each of these containers to run. And for an example where we've got the AZ balance spread, we're going to run our tasks across multiple availability zones. So what it would do in that situation is determine which container instances can support our task definition, make sure they've got enough CPU and memory, for example. We're going to sort those available instances by the fewest number of tasks that are running in each availability zone. And then we're going to place a new service on the new service task on a valid container with the optimal availability zone favoring the instance with the least tasks. And the same is true when removing tasks. It's going to try and maintain that availability zone distribution for us. And now we need somewhere to store our images. So ECS needs to load them from somewhere. Docker Hub is supported for image launching. However, ECR is tightly integrated, secure location that you can store your images, your Docker images. It's fully managed, so you don't have to operate any of your own infrastructure for your container registry. There's no software to install or manage or scale. You just push your Docker images into Amazon ECR, and then you can just pull them when you need to do a deployment using your standard tools. Secure images are loaded over HTTPS, automatically encrypted at rest. And then you can use IAM policies to control security and access around those images. It's highly available, redundant, durable architecture, backed by S3, so they're stored across multiple facilities. But the most important, well, I think most important, is the simplified workflow and ECR being integrated tightly with ECS. So we know that images are there, can be pulled and launched quickly when they need to be into our production environment. So just have a look at the workflow of a user. He's a developer. He wants to deploy his Docker image that he's gone and built into a cluster. He's had it running locally with no problems, and he's ready to deploy it. So first he's going to create a repository on ECR, and then he's going to push his image into that repository. Then he can create a task definition. As we said, we're going to say which container we're going to run. It can be one or more. We're going to set the CPU and memory requirements that are required to run this task. Then we're going to launch some instances into the cluster where we're going to run this task. And as I said, they can be different instance types all running within the one cluster. And then he's going to run the task or create the service. As we said, so a task is going to run once and ECS is not going to attempt to maintain state on it, whereas if we create a service, we'll maintain that desired count and try and keep those services running. And so now we're going to step through a demo and take a look at how it all works. So what we'll do first is we'll have a look at Docker Hub. We'll build a Docker file for Nginx. We'll open ECR, create a repository, push an image to that repository. Then we'll jump over to ECS, create a cluster, create a task definition, launch a task, we'll create a service, and then we'll stop some tasks to check the resiliency and create a load balancer. So just give me a moment and I'll bring that up. So here we are. We're just going to be working within the console today. You can do this with CLI commands as well, or via our API calls. So first we'll have a look at Docker Hub. So here are our base images, official repositories from Docker. Today we're going to be deploying the Nginx. And if we jump into that, we can see we get some instructions on how to set up our Docker file. And this is the example we're going to use. So we're going to say from Nginx, which is saying, okay, let's use the official Nginx repository. And then we're going to copy our HTML from our static HTML directory to the home directory, essentially on Nginx. So we'll jump over to our service and have a look at that. I'll just jump in. So there we have our Docker file. As you can see, it's very similar to what we saw in Docker Hub. Now I've already got the Docker tools installed on this system. So if you need them, you can install them for your system from the Docker homepage. So we'll just go back and we'll have a look at some of the others. So there are a lot of images available. We've got even like a full WordPress you can run, RabbitMQ, all easily available and use the same method to build and distribute those. So what we're going to do is push this up to our repository. So we'll go into ECS and create a repository. And we get started. Here we could step through a step-by-step to get everything running at once. So it's a quick start to set up our environment, but today we'll step through manually so we can see exactly what the steps are. So first we're going to set up our repository, and we'll call it the ANZ Webinar repository. And that's all we needed to do to create a repository. And then we've got very specific CLI commands that we're going to use to push our Docker image into our repository. So first thing we're going to do is log in, and we can just cut and paste these directly over into our terminal window. So the first one, we're going to do a login. and that's going to generate a secure login for us. And then I can cut and paste that login to connect. And we can see that our login has succeeded. So then we'll grab our next command, which is to do the build. So that'll happen fairly quickly. It had been run before, so as we said, Docker will only rebuild the changed components. It doesn't have to rebuild the entire thing because it's building in different layers. And now we're going to tag the instance, which is effectively a way of version controlling that into our repository. And we'll just tag that as being the latest image. And now we'll do the push, which will push it into the repository. And it'll take a moment to upload. So we'll go back over to our repository again. Close that. Now, if we ever need to come back and see those commands again, they're easily available here, and we can just go and do another push, for example. So let's close that, and hopefully we now have our image in our repository. So now we're going to create our cluster, and this is where we're going to start to deploy our image to. So we create a cluster. We'll give it a name of ANZ Webinar cluster, and we can choose our instance types, or we can create an empty cluster. So if we had an empty cluster, then we can start pushing out different image types as we want to into the cluster. But because it's a demo, we'll run two, let's say M4 larges. We can allocate our OBS storage that we require, and here we have the key pair that we can associate with those instances. Like as we said before, you can SSH to these because they are your own instances. Then we have the networking component. As we're saying, it just runs within your own VPC. I've already created a VPC for this. We'll add our two subnets across two availability zones. Security group, again, I've already created. So we'll attach that security to it and create. And so essentially that's all we need to do to create our cluster. And that'll take a moment for those instances to launch. So we'll just go and create the task definition now. And so the task definition is going to define how our container is going to run within the cluster on those instances that we just created. So create a new task definition. Here we can assign a role, and this is where we say it's tightly integrated with AWS. So you could have a role that's going to allow this container access to S3, for example. We choose our network mode. There's host and bridge. Won't go into those right now, but I'm going to choose bridge, which is the Docker bridge. And here we add our container that we're going to launch, and we're going to set the requirements, the sort of CPU memory around that as well. So we'll call that the webinar container. And we need that image URL, and I didn't copy that before, so I'll just go back and grab that quickly. And that includes the tag. I'll just grab it from here. So there we've got our repository and the image tag. Now we can set the memory limits for it, and we can set hard or soft limits, for this container. If we set a soft limit, it's going to be allocated that amount of memory, but it's going to be allowed to continue to consume memory up to what's available on that instance. So if we set a soft limit of 200, it can use 200 meg, but it can then continue to consume until the instance runs out of memory, unless we set a hard limit. And so let's set a hard limit of, say, 400. And then we have our port mappings. Because this is a web server, we're going to run it on port 80, but we're going to dive into dynamic ports in a minute, because we're going to restrict, we can only have one process running on port 80 on each instance. So that's where our load balancer comes in and helps distribute across dynamic ports. So we'll have a look at that in a moment. Then we have a whole lot of environmental network settings, very fine-grained control around what we can do with how this container is going to run. I can just leave those as the default values. And now we have our container, our task definition all set up and ready to go. We can hit create on that. And that's now created, and essentially I can go and deploy that task onto instances running within the cluster. So I go back to our cluster now. We can see we have our 2 container instances running. I'll dive in. We've got no services running. We can create one there. No tasks are running. And we can see our 2 ECS instances that are running. So let's just go and start one of those as a task. So we pick our task definition, the cluster we want to run it on, and the number of tasks that we want to run. We also have this task group that we can use, which will be used for our placement template. So if we have all the web servers in one task group and we're running a balanced spread availability zone placement template on that, then it's going to try and spread all those web servers across availability zones. So you can group your tasks together. So I'll just run one for now. I'll leave that blank and run the task. As we were saying, we would expect this to come up very quickly, within seconds generally. And so we can see that that task is now running on our instance. And if we go into that and have a look at how it's running, we get our external link. And if we go to there, we should see our container is running. It's version 1. So we'll go back and run another one, and I'll show you what we mean by those port limitations. So I'll run a new task. Remember, we're running 2 instances at the moment. So that second task I run will launch on the other instance that we have. So now each instance has both got a task bound to port 80. So that's the other instance. So both separate instances, both with port 80. And remember, they're just EC2 instances running in our VPC. So if I were to go and run a task again, we don't have an instance available that we can put port 80 on. So it's going to throw an error because we're out of ports. So now we have to go back and change that to be dynamic ports. And I'll show you what we mean by that. So let's just stop those tasks for now. We'll go back to our task definition, create a new revision of our task, and again we can change anything here, but what we want to do is change this dynamic port mapping, and I can set that to 0 or leave it blank, and that way it's going to choose a dynamic port to map to. So I'll update that and create it. And now if I go back to our cluster, and I can launch more than 2 tasks because they're going to get dynamic ports. So run task, let's run 10 this time. And we should see, we'll go and pick the right task definition this time. So we can go run new tasks, we pick our new task definition, and let's run 10 this time. Run task, and we have 10 tasks running across our 2 instances. And you can see again, they come up very fast. But this time, if we dive in, we'll see that they're bound to different ports. So this is where we can, now we can go and create a service. And the service is going to maintain that desired count of tasks running for us. Because if I were to stop half of the, let's stop a few of these now. They're just going to remain stopped. There's no attempt to bring those back. So we'll stop all of them. And now we'll go and create a service. So we pick our task definition, pick out the new one that we created, pick the cluster where we're going to deploy these task definitions. We'll give our service a name and the number of tasks that we want this service to attempt to maintain. We have a minimum healthy percentage and a maximum healthy percentage. And what this is for deployment. So we're saying, let's maintain a minimum healthy percentage. So if we do a deployment and things aren't working, it'll always try and attempt to maintain 50% of our desired number of tasks. So 5 in this case. And the maximum percentage is 200. So we can deploy up to 20 tasks during a deployment to complete that. I won't put an ELB on it for now, but again, we'll pick the AZ balance spread and create that service. So now if I have a look at this service, we can see we have our 10 tasks running. And if I were to go and stop those, or any one of those, so let's stop a few this time again. Let's stop those ones. So now they're not running. So because we've set that up as a service, we would expect the service to attempt to get back to that desired count of 10. And hopefully that'll happen fairly quickly. Any minute now. And there we go. So it's gone back to 10 of those tasks running, and they should start within seconds again. So that's good. So I've had a look at the tasks. We've had a look at services and the difference between those. Now let's go and add a load balancer in front of that for those dynamic ports. And I'll try and show you what we mean by that with a slide. So we have internet requests coming over HTTP port 80, and then we're going to hit a load balancer. And that load balancer is going to distribute those requests to the dynamic ports that will be running on each of the containers. And again, that's important because we can't have everything bound to port 80 within one instance. So let's go back to the console on that. We'll stop this service. Now, it won't let us just stop the service while tasks are running. So we need to set our desired count to be 0 before it allows us to do that. We'll update the service. And now it will allow us to delete it. So we can delete that service. So let's create a new service, and this time we're going to add it to a load balancer. I'll close these other two direct ones off. We'll pick our task definition again. The one with the dynamic ports is what we're going to pick. Service with a load balancer. Number of tasks, we'll just do 10 tasks again. AZ balance spread, but this time we're going to configure a load balancer to put it behind. I already had one set up because it's already provisioned and ready to go. So let's add our containers to the load balancer. We're going to create a listener port. So we want our load balancer to listen on port 80 with HTTP. Target group, so all our tasks that are running are going to be grouped into a target group, which the load balancer is going to point to. We have a path pattern. We're just going to point it at the root path, and a health check pattern because our load balancer is going to check for a 200 response code to make sure it's running okay before it's going to send any traffic to that. So now let's create the service again. So we're doing exactly the same as before, but this time we've got a load balancer in front distributing traffic across the dynamic ports to the containers. So that's completed. And I did have it in, I've got a shortcut here for it. It probably won't be available yet because we need to find some healthy instances. It needs the healthy instances first. So it's got to pass 2 health checks before they're going to become available. So we'll just wait for that to occur. If we go and have a look at the load balancer, again, we can go over to EC2. While we're here, we can see the 2 running instances. So this is all our containers are running on. We can go and have a look at our load balancer. Check the listener, listening on port 80, going to our ECS group. And here we can see the targets, which are those running containers. And we can see now that they're all healthy and running. And we can see they're also mapping to the dynamic ports running within ECS. So now we do a refresh and we can now see that we have a load balancer distributing incoming requests over multiple containers. So let's go back to ECS and let's push out a deployment across this. So we're going to go and change our code and do a deployment into ECS onto our cluster while it's all still running. So the way we do that is we need to, if we update our task definition here, it will trigger a deployment, which we should see in here. So we'll go back to our repository and get those commands again. Back to our terminal. And what we're going to do, so back on our terminal, we're going to update our HTML file and change this to version 2. Version 2, instead ECS Webinar Demo 2. I'll exit out of that, save it. All right, so exactly the same. All we've done is change our index HTML to be version 2, and now we're going to build that and push it into our cluster. So we don't have to, we shouldn't have to get the login again. So we'll do a Docker build. So again, very fast. Now we're going to tag it again as our latest image. And push that up to our repository. And we might wait for it to finish this time to make sure it's completed. So that's done. We should have a newer image here. It's been tagged as the latest image. And so now if we go and create another task definition revision of our existing one, we don't have to change anything because all we're really doing is getting it to push the deployment again. So I'll create that task definition, and so now we have a number 3. And if I go back to my cluster into our service, and then if we change our task definition, it should trigger a deployment of the container that we've just uploaded. So let's change that to Webinar Task 3, update service. And so now we can see that it has triggered a deployment. We've got what's active and what's primary. So active at the moment is the one that we're going to drain the connections from and move over to the primary. It should start having it fairly quick, but as I said, we do have to drain the connections from the load balancer onto the new containers. So just wait for that to occur. And then when it's completed, we should see this change to version 2. So I'll just go back to there, sorry, and check that again. We can see now that we're running, like we said, we could scale up to 200%. So now we're running twice as many services while we're draining connections from one to the other across the load balancer. And we should see this change to version 2 very shortly. Just refresh that one more time. Have a look at our deployment to see how it's going. So we now have the 10 running, but we also still have the 10 active running. And we can see version 2 has now hit production for me, but it could have happened to other people as well because the load balancer is distributing those connections into ECS. So that's it. So hopefully that's been enough information for you to dive in and take a look. We'll just go through, have a look at what we're doing again. So we had a look at Docker Hub, looked at the Docker files and built an Nginx service and updated the HTML. We did a deployment as well with that. Went to ECR, we created our repository, pushed an image to that repository. Then we used ECS. We created a cluster, created our task definition and launched a task, created a couple of services, one with and without a load balancer. We stopped some tasks to check the resiliency, and that worked as expected. So I hope that's enough to get things started for you on your ECS journey. I'll see if we have any questions that have been asked throughout the session that we may be able to answer in these last few minutes.